Hi, everybody. Welcome back to Dave's Math channel. I'm your host, David Tare, and this is my third video in my new series on the Math Lovers book. In case you guys are just joining this feature, this is all stuff from a three-volume series I wrote between 2019 and 2022. And this is available on Amazon.com in case you're interested in buying any one or any combination of these books. I think I should just give a little bit of an overview. First one is sort of high school level recreational math topics. Second one is more academic, more kind of undergraduate level. And the third one is problems and solutions. And the solutions to the odd number problems. And anyway, this is just my third video. I'm going through the first book right now, and talking about, in this video, I'm going to talk about place-valued number systems. So anyway, let's begin. So last time I talked about face-valued number systems. Those are number systems like Roman numerals, or it turns out there's also Hebrew numerals and Egyptian and Greek numerals, and they all involve a different symbol for a different number. And they're kind of cumbersome to work with, but these were some of the first number systems that were used. But a big innovation that was really kind of a important one in terms of mathematics was place-valued systems. These came later, and there were several ancient cultures that developed these. I think the first known one was the Mayans. Actually, unfortunately, they didn't survive. They started, I think, around 1 A.D., but then the whole Mayan civilization died out. I think around 950 A.D. Unfortunately, but they were one of the first known cultures to use a place-valued system. I'll get into that later. And I mean, there were a few others. The Babylonians used a base 60 system. I'll get into this more later. And the one we use today, the Hindu-Arabic system, the base 10 system, with the digits 0 through 9, is also a place-valued system. And the main advantage of place-valued systems is that it's much easier to do arithmetic with them. All the arithmetic methods you learn in grade school, like shift and add, multiplication, and long division, those work really well, but they only work for place value systems. They don't work for face value systems. It's much harder to do things like multiplication and division. Even addition is kind of hard with addition and subtraction with face value systems. So this is a big revolution. And anyway, let's get into this a little bit more. So, like I said, well, actually, it was the Babylonians who I guess came up with the first place valued system, and this was around, I think, around 2000 BC. They did this very early. The Babylonians were very advanced mathematicians. I think they were probably the most advanced of the ancient mathematicians, and probably mainly for this reason, because they were the first to use a place valued system. And their system involved, it's called sexagesimal. It's base 60. And I'm going to get into bases later. I'll probably do that in the next video. But 60 might seem like a pretty inconvenient base to work with since it's such a big number. But they used sort of two symbols, one for the ones and one for the tens. So here's a chart. If you look at this chart below, this is just a chart of all the symbols they use for the numbers 1 through 59, going from left to right. 1 is just a single vertical line. Two vertical lines, just sort of like tally marks, all the way to I guess. Um, well, they're wedges actually. They look like V's. So it's just a number of V's. That's the ones place. And then for tens, you use a sideways wedge to represent tens. So then by combining the sideways wedges with the upright wedges, you can get numbers up to, well, they did it up to 60. So they never used more than 5 sideways wedges, I guess, and they never used more than 9, vertical wedges. So they were able to represent every digit from 1 to 59, every sexagesimal digit from 1 to 59 this way. And by the way, our system where we use 60 seconds in a minute and 60 minutes to an hour, this came from the Babylonians because that's a base 60 system. And it was actually the Babylonians who invented that system. And I don't know how they were able to measure seconds, minutes, and hours. They probably didn't use it to measure time. Maybe angles. We use it for degrees, minutes, and seconds too for angular measure. But anyway, just thought I'd mention that that came from the Babylonians. Yeah, but the biggest problem with the Babylonian system is that they didn't have a symbol for zero. And the way they would represent a zero was just by not putting a symbol there. But that created a lot of confusion because, a lot of times you wouldn't know if the symbol's supposed to be there, if it's not supposed to be there. And that would give you two different numbers. So that was kind of a problem. But, just to give you an example, here's how you would represent a big number in the Babylonian system. So in base 60, you just go from it's kind of like how you do base 10. You start with a digit on the left. In this case, this would be the third place out from the units. I mean, on the right you got units, and the next to the one immediately left of that is your 60s instead of tens. This is 60s now. And then the one next to that is 3600. 60 squared is 3600. And the last one is 216,000. It turns out 60 cubed is 216,000. That's a pretty big number. But anyway, so if you wanted to read this number in the Babylonian system, the first digit is one. That's just one vertical wedge, and then the next one has, I guess, 7 vertical wedges and 5 horizontal wedges. So that represents the sexagesimal digit 57. So it's 1 comma 57. The next one has 4 horizontal wedges and 6 vertical wedges. That's 46. And the last one has 4 horizontal wedges. That's 40. Notice there's no ones in that. You don't really need them uh, if you don't have them. So if you converted this to decimal, it would turns out this number is equal to 424,000. I'm not going to do the calculation for you. You can do it yourself if you're interested. But the Babylonians didn't use base 10. They used base 60, so they would have written as 1 comma 57 comma 46 comma 40. Actually, I wrote it this way because they didn't have decimal digits either. But anyway, you get the idea, I think. And, it's a nice system. Like I said, the Babylonians were very advanced mathematicians. As a matter of fact, they did a really accurate estimate of the square root of 2, I think around 1000 BC. They were able to figure out the square root of 2 to, I think, something like 6 or 7 decimal places. They were pretty amazing, because of their math. I think it was mainly because of the system. And they did everything on these clay tablets. And another thing interesting I learned about the Babylonians, I learned this when I was taking a class in the history of science. I think around 1000 BC, they found there's some archaeologists that found a clay tablet from 1000 BC. It was a Babylonian clay tablet, and I wish I had a picture of it here, but it was a very, very complicated math problem. And to this day, we still don't know why the Babylonians were interested in this math problem. It was something involving astronomy, I think. It was either some really complicated astronomy calculation they were trying to do, or else it was a homework exercise for some poor kid, in ancient Babylon. So go figure. I guess we had, tough homework back in 1000 BC as well. So anyway, that was the Babylonian number system. And then the Mayans. I think I mentioned the Mayans already. And the Mayans were in Mexico, I believe. I think they were in the. I'm not sure. I think they were in the. What's it called? The Yucatan. I know there was Mayans and Aztecs. I'm not sure if they both lived there. But I actually went there a long time ago. I went there maybe 20 years ago with my girlfriend at the time. We went to Cancun and we went to see the Chichen Itza and the Yucatan, and we also got to see some Mayan ruins. And pretty fascinating culture. And like I said, they had a very good number system, another place valued system. These guys did have a symbol for zero. So this was a big advantage they had over the Babylonians. They had a shell symbol that was supposed to represent zero. And this was a base 20 system, also known as Vagetesimal, I think. And this is how you would represent the digits 0 through 19. And pretty simple system. The ones just are the dots. So you would use up to 4 dots. So 1 would be 1 dot, 2 would be 2 dots, 3 dots, 4 dots. And then, once you go beyond 4, you add horizontal lines. So each horizontal line, I guess that would be a stick. I think the Mayans used physical objects to represent their numbers too. I think they used an actual shell for 0. They probably use pebbles for the 1s, and they probably use sticks for the 5s. But I think they also wrote these down. So this is how they did their counting. And using this system, they went all the way up to 19. You'd have up to 3 horizontal lines or 3 sticks, if you like, on 4 pebbles. That would represent 19. So a pretty simple system. And just to give you an example of some numbers they would write down, these are representations for 3 different numbers. And I think one thing I should mention about the Mayan number system, they wrote their numbers vertically instead of horizontally. So the digits went up. They would start at the bottom and they would go up. So, for instance, here's some examples. I think the first example I show here is the number. What is it? 35. I can't even read it. 33. So you would start with 13 in the ones place, and then you would have a 1 in the 20s place, which represents 20. So it would be 20 plus 13, which is 33. And then the next example, I think, is 429. So you had a 1 in the 400s place, that's 20 squared. So that represents 400. You have 1 in the 20s place, so it's 420. And then there's 9 in the ones place, so that makes 429. And you can go even bigger if you want. I think the biggest example I have here is 5,125. So for that, you have to have, I think, 12 copies of 400. 400 times 12 is 4,800. And then you've got, what is it? 16 copies of 20, that's 320. So 4,800 plus 320 gives you 5,120. And then you've got a horizontal line in the ones place, that's 5. So the result is 5,125. So a pretty simple system. And I think they probably use base 20 because, we use base 10 because we have 10 fingers. But I guess they were using their toes as well. They were using their fingers and their toes. So you have 20 digits if you count your toes as well. I think that's what they were doing. That's probably why they used 20. They probably walked around barefoot, I guess. Maybe they wore sandals or something. But anyway, and I think I should make one other point about all this. They actually didn't use this system consistently. This was a disadvantage. They liked the number 360. And kind of obvious reasons. I mean, there's pretty close to 360 days in a year, 365, and 360 is a nice round number, close to 365. We also have 360 degrees in a circle. I don't think they use that system, but 360 is a nice number to work with. It's got a lot of factors. So a lot of times, at least for their calendars, they would use the 360 for the instead of 400. So in the top row, they would only use numbers up to 17 instead of 19. They would turn them over after 17. And this was a disadvantage, actually, because, it made it harder to multiply and divide. Having a consistent base is much, it makes it much easier to do math. But maybe they weren't interested in doing, complicated like shift and multiplication and long division. They probably weren't. They were more interested in their calendar. And by the way, I should say one more thing about the Mayan calendar. The Mayan calendar, the way it was originally set up, ended in the year 2012. And I don't know if you remember all the hype about the end of the world in the year 2012. I think they even made a movie called 2012, which I never saw, and I'm glad I didn't see it. But a lot of people thought the world was going to end in 2012, and they were even pointing at things from Nostradamus and all this shit. But the Mayans themselves didn't even predict that the world was going to end in 2012. It's just when their calendar ended. That's all it was. They didn't care about extending their calendar beyond 2012. And besides, they died out in 950 anyway. They didn't even make it to 2012. So, there's a lot of big hype over nothing. And usually that happens when people get all hysterical about predicting the end of the world. There were a couple other times in my life where this has happened. 1986. I remember when I was at the University of Michigan. A lot of my friends thought the world was going to end in 1986 because it was the year Halley's Comet came out, and people were also talking about the Jupiter effect where all the planets were going to be on the same side of the sun. That was actually 1982. And it was shortly after 1984, which was, the George Orwell novel, 1984. So there's a lot of hype, and people thought Reagan was the Antichrist and all this stuff. Each of his names had 6 letters, so they thought he was 666. I don't know, just a lot of bullshit. And they were pointing to Nostradamus. They were saying how Nostradamus predicted all these things that really happened. But they say that every time. Every time someone thinks the world's going to end, they always point to Nostradamus, and they always interpret as interpretations as things that are happening recently. They keep changing it, so I don't believe that stuff. And like I said, there were a couple other times people got hysterical about the end of the world. I think, even Prince had a song called 1999. A lot of people thought the world was going to end in 1999. It didn't. I'm glad it didn't. A lot of people were scared about Y2K. They thought Y2K would end the world. It didn't. I'm glad it didn't. And then in 2012, people got scared too, and they were talking about this thing called the perfect storm. It turns out, there's an 11-year sunspot cycle where, there's heightened solar activity. And, there was a thing called the perfect storm in 1859. And I guess it's a good thing we didn't have the internet back then because it was such a big magnetic storm. It probably would have wiped out the internet. And a lot of people are predicting that was going to happen again in 2012, but it didn't. So the world did not end in 2012. I don't know if it's going to end with Trump. It might because he's crazy enough. He might start an Armageddon. Let's hope he doesn't. But anyway, enough about that. Enough about the end of the world. I got way off topic, and I'm sorry I did that. But anyway, let's just continue. So that was the Mayans. I guess that's it. So anyway, thank you for watching. Long live math, and I'll see you guys next time. Bye.